when I stated that the plane was traveling at 300 meters per second at an angle of 45 degrees, I think I said north of east, right? Now, I chose north 45 degrees, and I think you know why, because you really couldn't screw it up too much. If I had said 30 degrees north of east, there is quite a chance that you wouldn't have understood how to apply north of east. Let's talk about that for just a minute before we go any further. It is a way in which I would like you to express cardinal direction. I will be stringent in my use of it. 45 degrees is relatively easy. But let's say I gave you 30 degrees north of east. Which one of these is more likely 30 degrees north of east? I can see it just fine. In agreement that there's now a blue line and a red line. One of them is 30 degrees north of east. So good that on a compass heading, 0 degrees is north. I don't believe it's particularly prevalent in this room because of all the time you guys spent with X being 0 degrees. So telling you that your heading is 235 might not translate as well to all of you. Do you understand why that's true now? So I'm probably not going to do that. I'm probably going to give you reference or relative positions based on north, south, east, and west. If and when we do this, we don't do this very much. But I need you to understand that all angles have complementary ways that they can be presented. If I was to write the blue, I would write it in an upside down division symbol like that. And I would say 30 degrees east of north. You guys understand that that's not what that is, right? That I wrote it backwards to see who I would catch? Okay. No, not enough of you. So that angle suggests 30 degrees north of east. And it could be written the same way as 60 degrees east of north. So when I gave you 45, I gave you something I didn't think you could screw up. But also, saying that something is northeast means nothing. Do you understand? You can't give me northeast as an answer because that covers everything between here and here. It's just not enough. So your first vector was the airplane. And it was 300 meters per second at 45 degrees. Let's call this out of the way. 45 degrees west of north. Sorry. North of east. I'm trying to talk in a hurry and I just can't do it. So here we go. About 45 degrees, look okay? So here's what I want you to do. When you're given vectors, I want you to draw them out because it's almost always best if you draw out the vector description and do a quick graphical kind of result. To do a graphical result, you actually add the vectors tip to tail. So this being the first vector, I've drawn it from the origin and drawn it in a scale that will work for me in my picture. Please make your pictures maybe bigger than one little line of your notebook paper. What are you saving that notebook paper for anyways? Spend a little bit of time. Spend some of the paper making sure that you are clear with the vectors. The next vector is pretty easy. Due west. And it should be about the third the size. So there we go. Due west, and it's about a third the size. When you draw the second vector, don't draw it at the origin. This isn't a free body diagram. This is a vector sum. I'm trying to provide a graphical answer, something that will help me with the solution. So these are my two vectors. They suggest a solution. They suggest a solution is a vector drawn from the origin to the end of the last vector. We call that the result. So this is the plane, this is the wind, When I add them together, I should get a result. So, questions to this point. This is a vector sketch. It's not particularly hard. The estimate helps, sure. And if I was measuring it carefully, I could measure this length of this R and use a protractor to measure the angle and be done. But what I want you to do is, after you've drawn a picture, the next thing you're going to do is convert to rectangular. This is done one vector at a time. So what I'm making right now is kind of a little place to keep track of my stuff. The polar for each of these is pretty easy to do. For the plane, 300 meters per second. This is an upside down division thing. It's just to separate the vector. It's just, and there are other ways to write polar notation. This is one. And it's 45 degrees north of east. The wind was 100 meters per second, and it was just west. Now, these are ridiculous size vectors, just so you know. 300 meters per second plane is a really, really fast plane. Speed of sound, 333 meters per second or so. So this plane is going very fast. And a 100 meter per second wind is a 200 mile an hour wind. Actually more like a 220. So we're talking hurricane strength gust. No planes flying in that except for maybe no plane is flying in that. So the hurricane planes fly over that. They don't fly through it. So your first job is to convert them to rectangular. Now, converting to rectangular is easy for one of them, but what I'm looking for here is I and J notation. It should be a sum of two vectors, one in the I direction and one in the J direction. This one is kind of stupid easy for the wind. It's negative 100 I hat plus 0 J hat. The plane, on the other hand, will require a little more work. So here, convert it over, 212 I hat plus 212 J hat. I've converted my vectors, bless you, to rectangular. Now just a point of note, you can have as many vectors in your addition as you need. And you can add and subtract vectors in the same way you would add and subtract numbers, now that you have got their components. So if I was to subtract the wind, I just make both of their components the opposite sign. So addition and subtraction work the same way now that you are in components. So just be careful though, getting to components tends to be the harder part. Since we are just adding the vectors, you add like components. Thus my discussion about notation. I can only add vectors that are in the same one-dimensional array. So I can add I hat components together and J hat components together. That's why you write vector sentences with the I and the J and the K, to make sure you don't mash those numbers together. So I'm going to add down the columns here, producing my result, which is 112 I hat plus 212 J hat. That's the answer. That's the result of the wind and the plane being combined together to a single velocity relative to the ground. Unfortunately, that's not how you have to express your answer. If you want all of the credit, you need to go backwards now and convert your resultant to polar. This gives you the magnitude and the direction. Now, my experience with last class period is that I still have to talk about even this. Because here we go. 239 meters per second. 62 degrees based on where it's drawn. It is north of east. Because 62 degrees facing east, turning towards the north. All the pieces again. The plane has a maximum airspeed of 200 meters per second. The wind is blowing 75 meters per second, 30 degrees west of north. For the plane to land traveling due east on the runway, what must be its direction of travel and what will be its ground speed? Good luck. A simple graphical idea. I don't know the direction of the first vector. I do know that the plane needs to land with a vector in this direction. I just don't know how long it is. I know that the wind pushes the plane back to this location. But the wind, right now, not attached to anything, is something like that. That's the wind. It's 75 units long, directed 30 degrees west of north. So I'm going to place it at the end of where I want the velocity to be. Remember, I want the velocity to be along the east. The plane is going to have a velocity like that. And I know this one's 200. This angle, I don't know what it is. I don't. I do know that the plane, though, is going to have 200 cosine theta I hat minus 200 sine theta j hat. Everybody okay with those? I know the wind is going to be, let's see, 75 and 75. I'm going to go with minus sine 30. And you should see why when you do your own work tonight in practice. And cosine 30. And ultimately, I know that when I add these up, this one should be 0. No component in the j hat direction. Do you realize when you do that, you are going to have a single sentence that can tell you what the angle is? Level 2. I encourage you who are still maybe struggling or maybe new to this to take just an extra second and draw a picture. Doesn't have to be much. You guys will have to rush to the answers though. You make those, what you call dumb mistakes, but they're just sloppiness and your need to be first. Then you sit there not saying the answer because you don't know if it's right or not. Just be careful. Take an extra second. Draw everything. Be aware of what you're being asked to do. You're being asked to convert this into components relative to north, south, east, and west. So I've drawn the vector, and now I'm going to draw in the components. There is a component along the x direction and a component along the y direction. One in the horizontal and one in the vertical. By definition, they are components, so they are already at a right angle to each other, because one will be the j component and one will be the I component. Now, when I look at this, I just see simple trig. I don't know what you guys see. But I don't want to teach trig. By making it 45 degrees, I knew you could screw up where you measured it from. Don't expect it that way on a test. You work this out, you should get 212. So this is my scratch page. So on my scratch page, I'm going to write out what I have now as a result. I have two component vectors. My component vectors are 212 in the I direction. I'm sorry, 112 in the I direction. And 212 in the J direction, giving me a result that looks like that. They are components, so they are automatically at a right angle. So now we're just talking about trig again. And I shouldn't have to teach. You can use Pythagoras if you like, but you're not getting away from trig. Since I'll usually want my angles expressed as degrees, you should check your calculator before you do this. So what's the magnitude? To what? 239 meters per second? And the angle's what, 62 degrees? Am I right? I don't remember. All right, 62 degrees. If you're still working it out, catch up.